I'm Dr. Gray. I'm going to be walking you through your experiment this week. Your experiment is one in which we're evaluating different solutions. We're evaluating a NaCl, which is backwards, a sodium chloride solution, a calcium carbonate solution, a sucrose solution. Now, if you are in 1341, then you probably know this, but what is the difference between each one of these solutions? I'm going to go ahead and present them like this, and then I can change the camera. Okay, so I'm going to put these two solutions together. Calcium carbonate and sodium chloride. These two solutions are grouped together because of the fact that they are both ionic solutions. This is a calcium ion and carbonate ions, making calcium carbonate, which looks a little bit like that. Looks like chalk. Well, the reason is because it is chalk. Okay, sodium chloride, standard table salt, also a white powder, okay, or a white grain substance. This last one, sucrose. Sucrose is a solid. It is not an ionic solution, but rather it is a molecular solution. So what we're going to be doing is we're going to be looking at the similarities and differences. Well, on one hand, similar, they look a little bit similar. They all have the same appearance, but if you were to be in the lab, you'd be able to know, or you'd be able to recognize that these have slightly different densities. And what I mean by that is they, well, this powder is much lighter than this powder, even though they fill up basically the same space. So that's one thing that makes them similar and one thing that makes them different from one another. But the way that we're going to be evaluating them is we're going to be evaluating them whether or not they conduct electricity. And the way that we're going to be doing that is with this setup right here. Now, what I have is a 9-volt battery. There we go. And this 9-volt battery has a positive terminal and a negative terminal. I've also got this little strand of lights, these two lights, and I've got a piece of wire. What we're going to be doing, and this might take a little bit of contorting on the camera here, but we're going to be putting different solutions into this 100 milliliter beaker, and we're going to be testing whether or not, well, the electric current can flow through this battery, then through this solution, and then be completed to, well, light up these lights. But before we get into that, the first thing that I wanted to address with this experiment, or the first part of your experiment, is these are known as controls, positive and negative controls. Positive and negative controls are maybe the most important part of any sort of scientific experiment because they give you kind of a foundation and a basis for comparison. So the first control that I wanted to show y'all was a positive control. And my positive control is to test whether or not this setup, this simple setup right here of these lights running to this battery will actually illuminate. So there we go. They lit up. And I think that these are the lights that if I flip it, it maybe lights up. And yeah, there we go. We got a different color scheme. These are the fancy Costco lights. So at any rate, this is a positive control. This tells me that, hey, this setup right here, this system right here works. Now you can make the argument that, well, you really do need another control of this piece of wire. We need to confirm that this piece of wire works. And you know what? That's not in your procedure, but I'm going to go ahead and do that right here and show you that. Oh, wait, it's tough to see. Yes, they do light up with this extra wire. So basically my entire system here works. Now, my negative control. The negative control asks you to get 100 milliliters thereabouts of deionized water. DI indicating, well, deionized water. Now the amount of water in here, it doesn't have to be specific. Or it's not important that it's measured. Okay, so what I want to do is I want to set up my electric current so that it runs through this water. So I'm going to be very careful and get this wire to connect with my battery. It's connected. Now, my question is, whenever these ends of this wire are in contact with the battery and contact with the water, well, will it light up? And you can see that no, it does not. And my connection is fine. This is basically my negative control that indeed ions have to be present in the solution in order for the current to run through. Now, my first experiment is going to be, well, using.
I'm going to turn on my digital balance. I'm going to put my weigh boat on the scale. I'm going to press T to tare it. Okay. Now, I'm going to get my sodium chloride solution, which is right here. I'm going to try to get as close to 1.00 grams, but I know that I'm not going to, and that's just fine. Okay, I got 1.08. I'm fine with that. And I can see 1.08. Do I know that number beyond that 8? I don't. It could be 1, it could be 2, it could be 0, it could be anything. I don't know.
Okay, now I'm going to get my weigh boat and transfer my sodium chloride into my volumetric flask. We'll also need on hand more deionized water. I'm going to transfer water into this until my bulb at the bottom of this volumetric flask is approximately half full. I'm going to swirl, 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 because I want this sodium chloride to go into solution. Now this takes a little bit of time, but you can see it's cloudy, but it's going into solution. That's great. What does that tell you? That tells you that sodium chloride is a soluble ionic compound. Great. Oh yeah, there we go. It's cloudy certainly, but do you see those large kind of chunks of salt? No, I don't. So now what I'm going to do is I'm going to very carefully continue adding water. Now, a volumetric flask is kind of tricky to work with because of the fact that, well, there's this large bulb at the bottom and it takes a little while to fill that up. But then once you get okay, now I've got my, see this etched line right here indicates 100 milliliters exactly. There's no markings on this piece of glassware outside of that. That's a very important distinction for this particular piece of glassware. It's extremely accurate so long as you use it properly. So now what I'm going to do is I'm going to transfer water. I want to get it down so that I can see the bottom of my meniscus. I think that's one of the, it's like everyone's favorite science word. So the bottom of my meniscus is perfectly in line with my etched line. So now I'm going to transfer my sodium chloride solution to my kind of experimental beaker. Okay, I've got 100 milliliters of the solution now in my beaker. Now, experimental trial number 1. I already looked at this and I know that, sorry, it's an ionic solution. It's a soluble ionic solution. I saw those ions or that solid dissolve. Now, it doesn't matter which terminal I connect to. I want to, however, get my battery basically in contact with my solution. And so here we go. That's lined up. Now the question is, will it light up? And yes, it does. So this tells me whenever I have sodium ions and chloride ions in solution, I get my solution to light up. That's great. Now the next part of your experiment is to make a dilution. And the way that you make that dilution is by transferring 25 milliliters of my freshly made 100 ml solution into this 25 ml grad cylinder. Okay, I've done that. The remaining 25 milliliters can go into my waste container. Can go into my waste container from the lab. Open this up. $75 milliliters. Okay, I put this back on because okay. Now I'm going to transfer my 25 milliliters back into my volumetric flask because I want to add 75 milliliters of water, of deionized water. And one way that I can do that is by filling this up 3 times. Or I could go and just use my volumetric flask again. I'm going to swirl this. And then I'm going to get all the way up to that line. Oh, careful. I went a little too far. So that throws my dilution off, but that's just kind of carelessness. I wasn't being careful enough. And I can't really take that volume out. Instead, I'm going to proceed on. Okay. So I've made this solution 1/4 as concentrated. I want to test if I see, well, basically the same. Do I get any sort of conductivity? Do I get my light system to light back up? Oh, I gotta get my battery light system good shape. Okay, there we go. So this has ions, like dissolved ions, but considerably fewer. Okay, well, it still lights up, so that's good. Now the last trial that I want to do is I want to do one last dilution. So I'm going to take 25 milliliters. Oh, what am I doing? I'm going to empty this out. But I'm going to take 25 milliliters of the solution that I just tested. Now, again, going to my waste container. I need to get 100 milliliters of this dilute solution. I made a mistake there. I need to adjust this up to 100 milliliters. Okay, I got my last dilute solution of sodium chloride. Is this ion concentration high enough to get these lights to light up? Is my question. Oh, you can't tell there. Or maybe you can. Yeah, you can tell. But my ion concentration, as it went down, the solution got the lights got much more dim. Okay, that's great. That's a great thing to recognize. My ion content, ion concentration, my soluble ion content. As it went down, so too did the ability for my lights to light up. Okay, so the last solution that I'm going to look at right now is my calcium carbonate solution. Calcium carbonate, I'm going to get 1 gram of it. I got, let's see. I got 1.06 grams of it. 1.06 grams. That I'm going to rinse out my glass. Transfer this into there. Ooh. If you've ever had to use like chalkboard chalk or sidewalk chalk and tried washing it off your hands, kind of tricky to deal with. So I've got my chalk in here, my calcium carbonate in there. Now what I'm going to do is I'm going to transfer the ionized water. It's super cloudy. Swirl, swirl, swirl. I don't see, okay, swirling, swirling. Okay, so this is a significantly different solution. This is super chalky and super cloudy. So if you were to compare these in terms of going into solution or not going into solution, I would argue that this one does not go into solution very well. So I would characterize this as insoluble. So now I want to know, does this light up my lights? So I gotta get my, Here we go. No dice, doesn't light it up. Okay. So no matter how much, or this is all of it. This is all of that calcium carbonate. So this is an arguably insoluble. And look at this volumetric flask, super cloudy on the interior. I need to dispose of this. My waste container.
All right, so for those, it's not shown the last 2 dilutions of calcium carbonate, but I do want you to go ahead and calculate the concentrations for those 2 solutions. You know, also operate under the idea that, well, if the concentrated solution was incapable of illuminating your light system, well, then those next 2 solutions are as well.
In order to do this, I've got sucrose, table sugar. I've got my light apparatus. I've got my 9-volt battery. I've got this extra piece of wire. And what I'm going to do is I'm going to get as close as I can to the appropriate solution. So I got this piece of glassware. I'm going to put it on my digital balance. Let's tear it out at 0. And let's see, I'm going to add table sugar until it actually registers a mass. Okay, so that's 2 grams. Okay, great. I've got 2 grams of water. Or 2 grams, I'm sorry, of table sugar. Now what I need to do is add water to it. So right here, what I'm going to do is I'm going to add water to this. I'm going to add until my mass is approximately 100 grams. Perfect. Okay, leave it at that. So I need to swirl this up. It's going into solution, all right. Continue, swirl, swirl, swirl. The solid at the bottom is getting kicked up, going into solution. Keep going. So this, it's pretty easy to see that, well, this is soluble. So sucrose, just like glucose or any other sugar, is a molecular compound compared to our ionic compounds that we looked at a moment ago. So this is a soluble molecular compound. This isn't to say that all molecular compounds are soluble, but this one in particular is. Okay, so that's, I think, sufficient for what we're looking for. Now what I want to do is set up my light apparatus or my lighting system. I might run into a little bit of a problem because I'm not sure if my, let's see, this wire, isn't it? No, that's going to be a little bit of a problem there. Okay, so, all right. Copper wire is in there. It's in contact with that terminal of my battery. Now I just need to get my lighting apparatus to come in contact with the solution. And battery, okay, so it is indeed submerged. Both terminals are in contact and no lighting. Okay, so there's a molecular compound that won't light up our solution or light up the lights.
Just like you saw with the calcium carbonate solutions, or the calcium carbonate solution, this molecular sucrose solution was also incapable of conducting or sending the current through the solution. So you can operate under the idea that those additional 2 dilutions would not as well. But I still want you to be able to calculate, and I want you to calculate those 2 dilution concentrations.